dear students, we are on the CEC-UGC lecture and we are in the series of electronic circuit. In this series, we are discussing the various electronic components and we are discussing the electronic cooling, and in this electronic cooling, today we will discuss the coolant. What is this coolant? Coolant is a substance, typically it is a liquid that is used to reduce or regulate the temperature of the system. An ideal coolant has high thermal capacity, having the low viscosity, and its cost is also low. It must be non-toxic, chemically inert, and neither causes nor promotes corrosion of the cooling system. Corrosion means when we are using the different type of wiring in the system, so the coolant should like that it should not corrode the cooling system. So coolant is a substance that typically a liquid and that is used to reduce or regulate the temperature of the system. Some applications also require the coolant to be an electrical insulator. While the term coolant is commonly used in automotive and HVAC. So as you see that in our car that we are just having the coolants. So in industry processing, heat transfer fluid is one of the technical term more often used in high temperature as well as the low temperature manufacturing applications. So the term also covers the cutting fluid. Industrial cutting liquid fluid has broadly been classified as a water soluble coolant as well as neat cutting fluid. So water soluble coolant is oil in water emulsion and it has varying oil content from the synthetic coolant like the nil oil. So this coolant can either keep it phase and stay liquid or the gaseous, or can undergo a phase transitions with the latent heat adding to the cooling efficiency. So when we used to achieve the ambient temperature, and more commonly a device is the refrigerant. So a coolant reservoir captures overflow of the coolant in a cooling system. If we talk about the coolant in the electronic circuit, and they are used to manage the heat, preventing overheating and ensuring the reliable operation. So they are crucial for maintaining the optimal temperature in the high performance electronic devices, especially in the application like data centers and high power equipments. So these coolants can be broadly classified into the dielectrics and the non-dielectric types. It means coolants are classified into two types. One is dielectric and second is non-dielectric type of the coolant, and each with the specific properties suited for the different cooling methods. So coolant in the electronic circuit is used for temperature control and the heat transfer, essentially preventing the overheating of any device or any system. So it is crucial for maintaining the functionality and the lifespan of the electronic component, especially in the high power applications. Coolants are used to prevent them from the high heating. So coolant are divided into the two categories. First is a dielectric, that is insulating. Another is the non-dielectric, that requiring the careful handling. So with example including the water, ethylene, glycol and various specialized fluids are under category of the coolant. So coolant methods are, first is the direct contact cooling and another is the indirect cooling. So we are having the cooling methods which are divided into two types. First is the direct contact cooling, second is the indirect cooling. So if we talk about the direct cooling, so the coolant is in the direct contact with the heat generating component. So coolant and the heat generating component are directly connected. So this can be achieved through the immersion or by using the cold plates. So sometimes just we put the coolants in the system, and then they are just in contact, like just if we want to have the cool the plates system, so we put the oil in that device, so it will cool the system correctly. So another is the indirect cooling. In this type of cooling, the coolant circulates through a closed loop, transferring heat away from the component to a heat exchanger, where it is dissipated to the environment. So in the direct contact cooling, coolant and the component are connect with each other, means the component are immersed in the coolant. Another is the indirect, where the coolant circulate through a closed loop, transferring the heat away from the component to a heat exchanger. So these type of the coolants are used in the various electronic devices as per its application. So it is important to select the best coolant for any specific device or the cooling system. So there are the some general requirements for the coolants, and they may vary depending on the type of the cooling system and electronic devices. So the liquid coolant for electronics must be non-flammable. Means the liquid should not be just caught by the fire. So it must be non-flammable. Another is it should be non-toxic, and it is inexpensive with the excellent thermophysical properties, because we are just cooling the system, so we have to keep all the thermophysical properties in mind just to select the coolant. And the features which include the high thermal conductivity, specific heat and the heat transfer coefficient, as well as low viscosity. So these are some points whenever we select the coolant for a particular devices, for a particular system. So we keep following features like high thermal conductivity, specific heat, heat transfer coefficient and the viscosity. It must be non-flammable, it must be non-toxic, and it must be inexpensive. So these are some of the points which we have to keep in the mind. Beside that, good chemical and thermal stability coolant must also be compatible with the material of the components of the cooling system as well as the devices. So in addition, if we take the high flash point, boiling point and auto ignition temperature are desired together with the low freezing point. So it is also noted that the selection of the coolant for the direct immersion cooling cannot be made by only using the heat transfer feature. Some of the chemical compatibility to the coolant with the chips and the other packaging materials must be considered as well. So heat transfer feature as well as the chemical compatibility, both we have to keep in mind for the selection of the coolant. So these are the following features. So as the water possesses the high thermal conductivity and the specific heat, and it is having a low viscosity compared to the other coolant. So it is the most widely used coolant for the electronics. So however, water is not used in the closed loop system due to its high freezing point and the expansion upon the freezing. So water is the one of the good coolant which can be used in the many devices as a coolant. So if we consider some key points for the choosing a coolant, there are some properties which have to keep in mind. First is the thermal properties. In the thermal properties, we have to note down what is the heat capacity, thermal conductivity and the boiling freezing point are crucial for the efficient heat transfer. Another is the electronic properties, in which we have dielectric strength and the electrical conductivity, which are critical for the safe operation of the electronic circuits. Another property is the material compatibility. So the coolant should not corrode or damage the component or the cooling system materials. Another is the environmental factor, which is the most important factor. It should not be toxic. So we have to keep in mind the toxicity. Second is the flammability and the environmental impact are important consideration. So the material which we are choosing must be followed by these features. Now we discuss the type of coolants, and here you are seeing on the screen that that coolant has been used in the industries depending on their own requirement, such as machining processes, materials to be cut, lubricity and the cooling effects. So a proper selection of the coolant is essential for the help of the us to understand which coolant benefits the machining processes and the workpiece along with the associated challenges. So commonly used conventional coolants are for the electronics are classified into two categories. First is the dielectric, second is the non-dielectric coolants, or we can say it is the dielectric fluid or the non-dielectric fluid. So first is the dielectric coolant. So dielectric fluids refers to the dielectric material in the liquid form. Dielectric materials we can take, but it must be in the liquid form that we can use. So the main purpose of the dielectric liquid is to prevent and quench electric discharges rapidly. So in this dielectric coolants, it is also important that dielectric coolants are used as insulators in the high electric voltage applications such as capacitors, transformers, switch gears, high voltage cables. So the function they provide is electric insulation through suppressing arcing and corona, plus they serves as the dielectric coolant. So dielectric coolants where just we have to choose a good quality dielectric liquid should contain a high thermal stability. These are some basic point and some features we have to keep just for the getting the just as we choose the dielectric liquid. So first is the what we have contain a high thermal stability. So in this high thermal stability, a high dielectric strength and inertness against the construction of the non-flammable. It should not be flammable. So we can have that they must have a high thermal stability. They must be low toxicity and the good heat material at a low cost. So dielectric fluid is a self-heating product. When an electric breakdown occurs, the discharge channel leaves a permanent conductive trace in the fluid. So these electric properties are strongly influenced through the dissolved gases such as carbon dioxide, oxygen, dust, fibers and moisture, ionic impurities. The electric discharge can cause the production of impurities which can degrade the dielectric's performance. So what are the dielectric fluids and EDM? EDM is the electrical discharge machining. So dielectric fluids are used in the electrical discharge machining as deionized water, and this helps to improve their performance. So they are also serves the following purposes, like they work as a semiconductors between the workpiece and the energized wire in order to maintain a controlled and stable condition for ionization. And moreover, they can be chilled enough to keep the workpiece, work table, wire and fixtures at a steady temperature, and this enables a limit to the thermal growth of the machine and workpiece so as to hold them in tight tolerance. So they act as a flushing agent to wash away all the ashy debris that were created when the cutting occurred. So dielectric fluids are also used just to wash out like we can say, or it can ashy debris, so that the clean surface we can get. So and cutting can be easily occurred. Another is the when the machine is distilled, commissioned and deionized, the low conductivity is used first. Then tap water can be passed through the bottle in order to filter out all the other contaminants and to neutralize the particles when the dielectric discharge. This can be done for cooling the system. So this water will then circulate through the micron paper filter so as to remove all the other remaining particles from the system. So most of these machines are usually equipped with the 5 micron filters. So that a micron, so that we can just flush out all the dust or ashy particles from the system. So what is this dielectric hydraulic fluid? That is also used for the purpose of the coolant. So this refers to the hydraulic fluids or the dielectric hydraulic oil that is formulated to perform in the specific hydraulic system that require the anti-rust, anti-wear, antioxidant. So, this property if it has, then we use the hydraulic fluids. So the specific application included in this category is the power utilities such as mobile, aerial lift buckets, stationary hydraulic systems. These are used for the various electrical insulation safety purposes. So the dielectric hydraulic oil ensures a high inhibition of the machine against the moisture that leads to rusting on both the seawater as well as the fresh water. So this is the basic purpose of the dielectric hydraulic oil. So the incorporation of the super high viscosity into a formula increases the index of viscosity past the synthetic level. So this type of oil are used, this type of fluid having the various group, and that are used for the coolant, which are aromatic, aliphatic and silicones and the fluorocarbons based fluid that must be used for the dielectric hydraulic fluid. So these are used for the basic purposes. If we talk about the dielectric coolant, so aromatic based liquids we can use, which is due to cheaper. Aromatic maybe like coolants are the diethyl benzene, toluene benzene and the xylene. These are the aromatic based liquid. So aliphatic based liquids in which we have hydrocarbon, aliphatic hydrocarbons of the paraffinic and isoparaffinic type, which include the mineral oil and which are used for the variety of the dielectric for the direct cooling of the electronic devices. So it is just in the contact with the system. So aliphatic polyphenols, so that is PAO based fluid that are used in the some of the electronic cooling applications. And silicon based liquids, and this is another type of coolant, and this widely used and which is known as the silicon oil, and these are the Silthum XLT. That is the main advantage of this class of the coolant is their properties such as viscosity and freezing point, which can be controlled by changing the chain length. So dielectric coolants are having the highest performance biodegradable, it is non-toxic, it is having a single phase dielectric heat transfer fluid available for the immense cooling of the electronic devices. So, made for electronic cooling, electro-cool, dielectric coolants feature the broadest material compatibility profile of the industry. So, the highest dielectric strength, which is having a zero environment impact as well as the safe for the health as well as the environment. So, dielectric strength and excellent are good in this type of liquid coolant. So, it is must having a heat high dielectric strength and excellent heat transfer. It must be have a fire resistance, it having a no sulfur, and that can be used safely, and it is non-allergenic, and moreover it can be used without extensive personal protective equipment. So, these are the some of the fluids which are using for the dielectric. Thank you very much.